All right, say hi. Jack, you want to say hi? As he throws the stuffed animal at me?
Hi!
All right, you guys go play and be quiet.
Hi, okay,
Okay, so Jack and Abby wanted to make a little appearance in this video. We're going to finish up
Junior! Elmo Teddy
1.8
Jr.
and Teddy Jr. We're going to finish up lesson 1.8 right now, just using that estimation now to figure out how many times bigger something is. So it says estimate the following problems using your powers of 10 and your knowledge of exponent laws. So they're not just going away. In 2015, the world population was about 7,390,000,000. The population of the country Rhett lived in was about 5,926,000. Hopefully I said that right. Approximately how many times greater was the population of the world than the country that Rhett lived in? So let's start by estimating. Okay, so our world estimation. So again, just like we were doing before, we're going to go to its leading digit. 3 tells us to round it down, so I'm going to leave this as 7 billion. Now remember, we can write with the power of 10 as 7 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that one wasn't on our chart, but remember, we can with tens, we can use that hint of the number of zeros. When, remember, it is decimal, really small numbers, we count decimal places. Okay, so right here, if we do the country Rhett lived in, that 5, the 9 tells us we're going to make this 6 million. Round the 5 up. Okay, so I'm going to rewrite this as 6, 1, 2, 3, 4, 5, 6. 10 to the 6th. Now let's talk about how many times greater. All right, the hint comes right here. We want to know how many times greater was the population of the world than the country. So we want world over country. So the world is right here. 7 times 10 to the 9th over 6 times 10 to the 6th. So remember, if we just focus here, don't, I'm sorry. I have to backtrack a little bit. We're estimating, so I want these two numbers to be the same. So yes, this should be 6, but we want to make these problems really easy. So since the world population rounds to 7 billion, we're going to round the country's population to 7 million. Okay, that's not a close approximation, but we're trying to actually make these problems just really easy. And when you're dealing with millions and billions, what's a million, right? So if we make that 7, 7 divided by 7 is 1, so that's gone. And then our exponent rules. Same base dividing, we subtract. So how many times greater is it? It is 10 to the 3rd times greater, or 1,000. Okay, so on what we're doing right now, we're really going to work on making these first numbers the same, and then we'll work later about what happens when they're different. So let's try another example. The diameter of a grain of sand measures about, let's see, tenths, hundredths, thousand, 10,000. So 46 10,000ths, 0.0046 inches, while the diameter of a dust particle measured about 0.00005 inches. How many times larger is the diameter of a grain of salt than a dust particle? So the same thing here. And again, I want to keep those first numbers the same. Grain of sand estimate. Well, I look right here at the 4. The 6 behind it tells me to go 0.005. So that's going to be 5 times, now count this is the power of 10. Count the decimal places, not the zeros when it's really small. 1, 2, 3. Except, remember, it's a small number, less than 1. We make it -3. How many times is what is the approximation of a dust particle? Well, that is a 5 right there, so we're going to leave it the same. So this is going to become 5 times 10 to the, count the number of decimal places. 1, 2, 3, 4, 5, and it's really small, so it's a -5. Now we want to know how many times greater. Sand to dust. Okay, so our sand is 5 times 10 to the negative third. Our dust is 5 times 10 to the negative fifth. 5 divided by 5 is 1, so let's focus right here. Same base dividing, we subtract. Now be careful subtracting. We get negative 3 minus a negative 5. So keep, change, or subtracting is the same thing as adding the opposite. So if we go negative 3 plus 5, we get 2. So how many times greater is it? 10 to the second power, or 10 times 10 is 100. One more example. And notice we're just kind of doing the same thing with these here. And I can't scroll anymore, so I'll come down here. A small town in Texas started with a population of about 1,200 people 50 years ago. Now the town has experienced significant growth and has a population of about 1,320,500 people. Approximately how many times larger is the current population in Texas than it was 50 years ago? So let's take our leading digit here. Okay, that 1, so the 2 behind it wants us to leave it as a 1. So that's 1 million. This one right here, that 3 behind it tells us to leave this as, I'm sorry, that's 1,000. This is 1 million. Ooh. Okay. So 50 years ago, this 1,000 right here, that is a 1 times 10 to the, count the zeros, 1, 2, 3, because it's a number bigger than 1. Okay. Ooh, I write that better. Okay, and the current population, that's 1 million, so it's 1 times 10 to the 1, 2, 3, 4, 5, 6. All right, so how many times greater is the current population than it was 15 years ago? So we want current over 50 years ago. Okay, and it's kind of, you always, in this case, want to put the bigger number on top because we want to know how many times bigger it is. So the current population is 1 times 10 to the 6th over 50 years ago, which is 1 times 10 to the 3rd. So again, those ones are going to cancel out, and I'm left with 10 to the 6th over 10 to the 3rd, same base, subtract the exponents because we're dividing. And again, we get 10 to the 3rd, or 1,000 times greater. These are just rough approximations, but again, when you're dealing with such big numbers, sometimes those, kind of rough approximations or estimations work really well. And like I said, this is also going to lead us to scientific notation. So the big thing is to focus on is just the little hints I gave you about writing times powers of 10. And then also, you're kind of putting the bigger one on top here. Whatever one they're saying, how many times larger is this one compared to that one, you want to put the bigger one on top.